Hi everyone, today we are going to learn about binary search in sorted array. Binary search is only applicable when given array is sorted. So suppose we want to check number 6 exists in the given array or not. Suppose given value is 6 and given a sorted array is this one. We want to check number 6 exists in this array or not. So what we can do, we can apply linear search. So we will start from 0th index and we will check first element is equal to 6 or not. It is not, then we will go to next element. So it is also not equal to 6, then we will go to 3 is also not equal to 6, then we will go to 4 is also not equal to 6, we will come to 5 is also not equal to 6, then we will go to 6. So here given value and this element now 6 matches, so it means this given value exists in this array. So in this case it will take 6 steps, 6 iteration to find out given value 6 exists in this array or not. Suppose we wanted to search for 1, given value was 1 only, so it will take 1 iteration only. So at 0th index we can say 1 exists in this array. So this is the best case, it will take only 1 iteration. Suppose given number was 10, so here we want to find out not given number 10 exists in this array or not. So it will take 10 iteration, 10 steps it will take. Okay, at reaching last index we will able to say given number 10 exists in this given array. Okay, suppose we wanted to find out 20. Okay, so after at reaching to the last index we can say like given number 20 is not exist in this array. So for finding last element in the array or number which is not exist in this array, so it will take 10 steps. 10 is size of the array. Okay, n equal to 10, this is size of the array. So this is the worst case. In worst case we have to traverse through each element in the array. So time complexity for linear search will be order of n in worst case. Okay, so now we will try to apply binary search for this given array. So we already know, since array is sorted, first value will be always lowest value in the array and last value will be always highest value in the array. Okay, so according to binary search, first we will look at mid element since array is sorted. So here mid element is 5, given value is 6 and mid element in this array is 5 and 5 is not equal to 6. So while looking at mid number we can divide this array into two parts. So the first part will be number appears before 5, which is mid element. So this will be first part, number appears before 5, and second part will be number appears after 5. Okay, 6 7 8 9 10. So this number 4 will be mid minus 1. Okay, index of this number will be mid minus 1 and 6 will be mid plus 1. Okay, since mid is 5, given value is 6 which is greater than 5 and all numbers in first part are lesser than 5. So given value 6 can't exist in first part. So we will ignore this first part and we will only try to search given number 6 in second part. Okay, here we can see this second part as a new array. For this array low will be 6 and high will be 10 and 8 will be mid element and 8 is not equal to 6. 6 is our given value which we need to search 6 exists in this given array or not. So mid is not equal to 6. So while looking at mid we can see this array as a two parts. So first part will be numbers appears before 8. Okay, and second part will be number appears after 8. Okay, so this number 7 will be mid minus 1 and 9 will be mid plus 1. Since mid is 8 and given value 6 is lesser than 8, so 6 can't exist in second part. Okay, because in second part values will be always greater than 8. So we will ignore this second part and we will focus only first part and we will try to find out this given number 6 exists in first part or not. Okay, so we can treat first part as a new array. Okay, so low will be 6 and high will be 7 and mid element for this new array will be 6 only. So first we will check given value 6 matches with mid element or not. So mid element is also 6 and given value is also 6. So we can say given value exists in the given array. Okay, this is the given array and we want to search 6. So in above procedure we check 6 with mid as a 5. Okay, this is first step. Then we have divided this array into two parts. Then we are checking 6 with mid, which is 8. This is second step. Then we have divided this array into two parts. Okay, then again we are checking 6 with mid element, which is 6, and this is third step. And in three steps be able to find out given number exists in this array or not. Okay, in case of linear search we have to traverse through the all elements in the array. Okay, but here we are not traversing through 1 2 3 4. Okay, we are comparing 6 with mid element, and we are ignoring this first part. Okay, we are not traversing through 1 2 3 4. Okay, then again we are comparing 6 with this mid element, which is 8, and again we have divided this array into two part, first part and second part. And while looking at mid element, which is 8, we are ignoring 9 10. Okay, we are not traversing through 9 10. So in binary search we don't traverse through all elements in the given array, so that's why it is faster than linear search. Above steps we have followed sequentially is known as binary search algorithm. So array being sorted is precondition for binary search. Now suppose we want to search 4 in the given array. So we want to search given number 4 exists in this given array or not. So obviously mid will be 5, and 1 will be lowest value, and 10 will be highest value. So we want to search 4 exists in this given array or not. So first we will compare given number 4 with mid value. So mid value is greater than 4. So and values appears after 5, which is 6 7 8 9 10 will always be greater than 4. Okay, so we can ignore this greater values. So we can ignore these values, and we can focus on first part. So we can treat this first part as a whole new array. So low will be number 1, and mid will be 2, and 4 will be highest number in the array, since array is sorted. Okay, so now we will focus on mid element. Now we will check mid element with the given value. Given value is 4. So mid element is lesser than 4. So elements which appear before 4 will be always lesser than 4. So we can ignore first part. So we will ignore these elements. So second part we can treat second part as a whole new array. So low will be 3 and high will be 4. Okay, high will be 4 and mid element will be 3 only. So now we will check mid element with the given value 4. So mid element is lesser than 4. So what we can do, we can ignore numbers appear before mid element and mid also. So we will focus on second part. Second part will have only 4. So low will be 4 for this case, and high will be 4, and mid will also 4. So we will check mid with our given value. Given value is 4. So mid matches with given value. It means given value 4 exists in this array. Okay. So for finding 4 in this given array, it will take approx 4 steps.